Okay, hi. My name is Pranav. I work as an engineering manager right now at GeekyAnts. It's been almost 6 years with the organization right now. Started off as a developer and then added responsibilities. And now I'm a engineering manager. So for the last 3 years, just to give an introduction, like what we've been working on is that I've been working on an application which is pretty big. It's a supply chain dashboard for an organization, and uh, we've run into a lot of issues, solved a lot of issues, found a lot of learnings through that process, a lot of things that we shouldn't have done, a lot of things that we should have done. So what I'll be doing today is that I'll be taking you through that journey basically. Um, let's start. Okay. The basics of a supply chain dashboard. So when I say supply chain dashboards, what do you guys think it is? Is it a simple dashboard? You have like 100 items displayed. You have your tables. You have your uh, you know you have some data visualization, and that's it. But when we talk about large scale supply chain applications, the way they work is that each page and each grid, and there is not one, there are like multiple grids, and each of them are going to hold records that will exceed 5,000 at any given point of time. And this application that you're building, you can start off in any manner. You can start with a CRA, you can start with a ejected app also, you can start with a next app or whatever you can choose. But the problem is that once you start with one code base and you start building this, then you run into issues not at that point, but a year later. Because that is when your team will decide to scale. That is when your team will decide to say, hey, I need more features. This doesn't look enough. The end users, the people who use your application, they now have requirements. They're like, hey, we like this, we like what you've built, but can we have this feature uh, along with this? Is that doable? And then at that point of time, your architecture, will it support it or not, becomes kind of a slippery slope, because you started off with one code base and now you don't know, if I change this, what's going to happen, how many components is this going to affect. So one of the basics is the size of the application. The second one would be user management. When I say user management, a supply chain dashboard typically does not have a lot of users as, say, a social media site, right? It will never have those kind of users. But what it does have is that each one of the users on a supply chain dashboard will have different roles. They are not all the same users. You play around with permissions a lot. So what you're doing is that each person who's logging in gets modular access to your application, and they can access parts of it. Only, for example, admins or super admins can access all of your application, but apart from them, it's very modular. And that proves to be a problem if you stop handling your permissions correctly in your one code base. But yeah, that's one of the problems that happens down the line. Effective data visualization, yes, again, when you are having the kind of records that I talked about, like which are in excess of 5,000, you can't just scroll through that. You need good visual representation so that whoever logs in, whoever looks at your dashboard knows that, hey, okay, this is what I'm looking at. 3,000 of these are done. These are pending. These are done from my side. This is pending on someone else. And they can get an idea of what the state of the application is. And that's very important on a supply chain dashboard. Order fulfillment and shipment tracking is basically, if there are like multiple entities that are logged into it, you need to make sure that if you have made an order, you need to track it, you need to see if it's done, if it's returned, if it's defective, and all of it needs to be tracked. Because when you're talking about supply chain dashboard, it's between, for example, a manufacturer and a supplier on the other side, right? And they're sending stuff, and there will be a lot of cases where you're not satisfied with it, or you're not satisfied with the pricing, or you're not satisfied with the material, and those things will play into it. So we need effective way to track them so that we can put them requests for changes and stuff like that. The next part is something in addition, but I feel it's something that's very important, which is a communication channel. So ideally, if, for example, you say there's a manufacturer and there's a supplier, right? Now, what happens is that if if they don't have a communication channel, they will fall back to their usual communication channels, which is an email, or if an organization has Slack. But each supplier, for example, is a member of another organization, and to onboard them on something like Slack would be a bigger pain than using it actually. So they will fall back on using emails, but if you built an inbuilt communication channel into your dashboard serves as the one-stop solution for everything. They don't have to leave your application. So that's also an important thing that we can usually add it at the end, but yeah, if you can build it from the start, that's even better. So these are kind of things that we are looking at when you're building a supply chain dashboard. We started with building a supply chain dashboard, not knowing the scale of what we are building. We started with a CRA app. Everybody here has done it, right? We started with a CRA app. We said, hey, what's the problem? We can go ahead and build it. There's no issue. We started building it. We built one table. It had around 2,000 records. We were fine. We dealt a bunch of issues with performance, but apart from that, we were good. Okay, then came another screen that had linked to 5 other screens. Now our code base started to get so heavy. Each deployment was taking 20 minutes to complete because the code base started getting so heavy that we just couldn't deal with it. Like if there's one change coming through, a change request, now we need to make sure that 50 components that use that small piece of code are not getting affected. So first of the things is you need like a huge test coverage just to have it, and we didn't have that also at the start. So it was a very slippery slope, and we could see that this is not going to improve soon. So that's the complexities that we started facing with that application. So no separation of concerns. When I say no separation of concern, it means a component that I've built is not serving one purpose. It's serving a bunch of applications in different ways. And that's a problem. If it's a shared component, it makes sense. Yes, hey, this is a searchable dropdown. Go ahead, every part of your application can go ahead and utilize it. That can be shared. But if it's specific for some function, then it should remain so. It should not be configured along with that with some additional props, and you're trying to configure it for another use case. So there's no separation of concern. Overwriting of existing changes. This was another big issue. I finish a ticket. I say, hey, okay, this task is done. 2 months later, some other developer onboards. He gets a task to change it. Both of them are using the same component. You make some changes. My code, which is in prod, which I did not touch, which did not have any changes, now suddenly breaks. Yeah, there's another inquiry. Why is this happening now? So that was one of the big problems, the practical problems that we faced. No independent deployments. Yes. So you are always dependent on the rest of the application. So if all of your code is, for example, on one branch, right? You're in QA, for example, and then you want to go to stage. Now you want to do a QA to stage, but you're not sure all of your code in QA is ready to go to stage and go to release, right? And then you get into problems because the whole deployment is controlled at a singular point, and now your whole application gets deployed, whether you want it or not. Release plans. I don't want to talk about this. The problem with release plans was that exactly the thing that I talked about. QA to your higher branch, for example, stage, if you're going to, for each release, we started having 20 commits, right? We started having 50 commits. The team size was close to 35 developers. Each release started to have more than 200 commits, which had to be cherry-picked. If there are conflicts, they need to be resolved. There's one person who's responsible for all of this, the DevOps guy. He's losing his head. There's no way he can do this without, a lot of input from each developer. So each developer needs to come sit with him for 20 minutes and say, hey, no, pick this one. This is actually my code. I don't want this. And then we basically developed for 1 week and we released for the other week. It was a 2-week sprint. And we developed for one and we released for one, which was not something that we really wanted to. So how do we solve these problems? And mind you, we are in production right now. We have a lot of end users right now. So what do we do at this point? The solution was Microfrontends. We explored a couple of options, but this was the most straightforward thing that we saw at that point of time. It made sense, especially because supply chain dashboards kind of serve the exact purpose for which microfrontends are ideally built for, because you have modular access, but you don't have a lot of connection between one part and another. For example, if your supplier logs in and they try to access their admin screens where they update their address, hey, this is my address. If you want to pick stuff up from this supplier, you go to this address, right? They have their admin portal. That admin portal is not at all related to if an admin or a guy who is associated with purchasing logs in and sees the list of orders. He cannot change those values because it's a supplier address. He doesn't need to view those. He can view those, but he'll view those when he actually orders some parts, right? There's no reason for him to view those. So it gives a very, it's an exact use case for us. So yeah, what it does basically, a small introduction about microfrontends. It decomposes a monolithic front-end app into smaller units. So when I say monolith, it means, for example, you have your CRA app, or you can have a Next app for that matter, or you can have an ejected app, which you've already ejected. But the whole point is the code base is singular. There's a single entry point, and all of your modules are hosted inside of the same space, right? So what do microfrontends do is we take out modules. Each module that's not going to interact a lot, and that's a decision that you will have to make, like where you draw the line on how much it interacts with the existing part of your dashboard and how much can be separated out. So that's a thin line, but you have to draw it once as a developer. You decide that, hey, I want to go ahead and delete this into like 5 parts. So you decide what functionality goes into which of your modules. So it enables engineering teams to control their own deployments. Sure. So if I want to deploy, I'm not waiting on the other team. You can go ahead, deploy at your pace. If I'm done quickly, I want to do 1 week sprints and I want to have a release after each sprint, I can do it. I don't need to care about your code, or if it's moving fine or not. Maybe they have some blockers. Maybe those are genuine. Like, you don't really need to care about what the other team is doing. Avoids technology lock-ins. This is another thing. So I want to use Material UI. The other team wants to use vanilla extract. Now we are kind of stuck. We're having to and fro that, hey, this is the benefit of using an inbuilt library. They're like, I can build it myself. And then they want to use vanilla extract. So you don't really, there's no lock-in. You can go ahead, you can use your own state management. You want to still use Redux, go ahead. You want to use context, go ahead. Whatever you want. Which is a great thing to have, especially once the team gets bigger. Client-side composition. So the way we built microfrontends was client-side composition. So everything was happening in the browser. All our main shell app and the microfrontends that we've built, all of it survives together in the browser. That's where it's compiled. Enhances scalability. Yeah. So this is again goes back to the first point, which is like multiple engineering teams controlling their own deployments. So you can scale. You can say, hey, I want to just expand on this feature without affecting anything else, and you can pretty easily do that. So there are a lot of benefits, but yeah. So how do you actually implement this though? Okay. So this here is an example of a supply chain dashboard, for example, right? So you can see the nav bar. It's a pretty overcrowded nav bar. There are a bunch of drop downs that you see, each of them pertaining to a specific use case and to a set of approximately 50 screens, each of them. And all of this, when we started off, was surviving in like one application for us. So our task became basically to divide this dashboard into a lot of smaller chunks, and assign which team will work on that part of it. So each of these drop downs, we broke it down into an individual micro frontend, and you could not even stop at that. For example, if you look at, there's a column that says RFQ summary, there's a column that says new part releases, right? New part releases is a graph display. RFQ summary is a metrics display that we are seeing. You can go ahead and host both of them in separate micro frontends, or the dashboard that you see below in the loading state. You can go ahead and put that into a separate micro frontend. And all of your three big contents that you see on this page can survive on their own. They have no dependency. You can use your own styling if your dashboard needs some external libraries, right? Which other libraries don't really want to. You can go ahead and use it. But it's your call. Like, at what point as I mentioned, do you want to break? Do you want to break all of this? We didn't, because the APIs, everything was similar, and these actions were not taking a lot of time. There was no point in breaking this down because there was not a lot of visual dependency or a lot of graphs here that were taking time to render. So we decided to break this down, each of these drop downs, into separate microfrontends. I'll give an example now. So for example, if you have your application, right, it's hosted, you have a URL, that's the URL that you access. How do you break it down into a microfrontend? First thing, you create a shell app. So first things first, don't create a CRA app when you start to do this. You can, there's not to say that you can't, you can for sure, but you will need your webpack config file. So eventually you will have to export it out, right? So you have to eject your app basically. So try to start with a plain npm init your JavaScript application, add a webpack config, add a package.json, and just get at it. So what you do with your shell app is that it consumes all your microfrontends. So the task of the shell app right now is just to take in all the microfrontends and display them wherever they are supposed to be displayed. So for example, in the previous, in this view, you can see the navbar, right? The navbar can ideally survive in a shell because that is not dependent on each of the microfrontends. But as soon as you click on that drop down, as soon as you link that route, right, but the component that you return can be a microfrontend, whether you want to return your dashboard or your metrics, right? So these are, for example, each MFE that you have, metrics and dashboard. Each MFE has its own backend environment. You can host it separately, and all it's doing is serving your front end, and it's not dealing with anything else. If there are like common functions, you can export them. If you're, for example, using an AWS environment, right, you can export them into a Lambda or somewhere. But the backend itself, the schema of it, it's hosted separately, no connection to the other MFE. Along with this, you can also use your shared component libraries on the side, or you can use some grid libraries that you want, for example, AG Grid, or you can have some other shared libraries as well. So your shared component library is like, which follows your basically your organization's design system and builds components up, right? That can be a common library that all of your applications use, your shell app, your dashboard FE, and your metrics FE. And it just has to be installed in each of them, directly use it, no changes. Okay, let's get into a bit of code now. I've just taken out parts of it, not the whole code base. So I'm just going to show you the webpack config. So this is my shell app, which is the parent app, which combines all the individual applications, right? So what I'm doing here is that I'm adding a new module federation plugin. So I'm using Webpack with module federation. Webpack 5 has some great improvements to use module federation. So for example, I've named this as my shell, and I've added a remote to it. What's my remote? It's running on my localhost 4000 at moduleentry.js. So it's a simple app, like when you run a normal app on when you do a yarn start, right, for a CRA, or if you're doing a yarn start for a Webpack ejected build. Either way, this is where my app is running. So this is completely runtime though. So what's happening here is that this shell app is running on 3000, but the 4000 is for my micro frontend. I'll come back to the line at the bottom, but yeah. So this here is my MFE. This is my individual micro frontend, like dashboards FE or my metrics FE. What it does is it exposes what's the entry name of the file and what's the name of my mod plugin, basically the one that I'm adding, and what does this module actually expose. So I've currently exposed the app, which is src/app, and along with it I created a button. So it's a small button component, and I'm trying to export that also from the same micro frontend. I could go ahead and host this button in another micro frontend, and all I'll need to do is just change the access, the remote access of this application. So this one currently exposes app and button. How would you go ahead and use this? So run this application on 4000, go ahead, and your shell is running at 3000. Now, how do you use it is a lazy import on your remote. So we defined that as remote, where our individual MFEs was hosted. And what we're doing is we are just importing what we exposed. We expose app, we expose button. We're importing both of those. We go ahead and render them here. So I'm in the host, which means I'm in the shell. I've just rendered an application. The remote app key that I'm seeing here is not a part of this application, nor is the remote button. Both of these are coming from their individual micro frontends, but I can easily render them here. Show up this, pardon my CSS, but yeah, this is how it shows up. The button that you see and the hello from the other side is basically coming from another application. You can run all of this together in your shell. This is a very basic example of how you run these micro frontends. It's not very difficult. It's just webpack config. Don't ever fear webpack config. It's new sometimes to us, but it's pretty straightforward. Okay. Nice. So one of the main things that we found after we did this was that our application became like a rainbow. We could not identify which element was where. Instead of the dashboard, it was covered with a red background. Instead of my metrics, I am seeing the component elongated even bigger than my whole screen. So it was all a mess. You could not see anything on the whole application. And this is a prod app that we're talking about, right? What was actually happening was that each MFE was using Material UI. And Material UI is great and it works very fine. In development, it does not care. So in development, what's going to happen is you assign a class name, right? You assign a class name to your div. You say it's hero content and you make a bunch of changes to it. You say, I want to give it a padding and this. So what it's going to do in your dev environment is that it's going to append it with your make styles, which Material UI exposes. And then it's going to assign whatever padding was there. And this is fine. We have no issues with it. But in production build, what happens is that it tries to save a lot of space. When it wants to save space, this long name .makestyles -hero content -2 is too long for it. So what it does, it randomly generates strings which it assigns to those specific styles that you've defined there. Like for example, whatever your padding is. So for example, it defines JSS1 as, and it defines your padding as 8. Now the problem is multiple MFEs are using the same library, and in the production build, all of them are creating multiple .jss1. One of them has a padding, one of them has a border, other has a specific height. And this problem is arising now because these micro frontends don't really talk to each other. This will never happen on a monolith architecture, right? Because they know that, hey, this is not unique, this is already created. So if in one micro frontend, these .jss1 will always be unique. It will be .jss1, .jss2, and so on. But multiple micro frontends, they don't know about this. So we didn't prepare for this, but this happened. So we started looking into it. Material UI, on its behalf, it knew about this. It basically provides us with a create generate class name, which provides you an access to basically enhance it and make your own class names. You add a prefix to it, and each prefix is for a specific micro frontend, which is a unique name. Go ahead and add that prefix to your generated class name, which is like JSS1 or JSS2, and then this becomes unique, and you never run into any issues with your styles, basically. You pass this to the styles provider, which is again exported from the Material UI core. This was one of the big problems that we had, but yeah, it's solved pretty quickly, but yeah, we didn't account for this. Fine. Some considerations before you jump to make your application into a micro frontend. Migration from an existing architecture is a big task. You need to make sure all of your team is on board with this before you start doing this. The application that I worked on, I had to take out approximately 120 screens and from an existing production application into a separate MFE, and I expected it to work as it is seamlessly, which is not going to happen. It took me 3 months to do it, which is a big task, but we did it after 2 years of development. So 2 years, 15 developers working on our app. So you can see the size of that application was. So it is going to be a big task. Make sure everybody's on board with it. Complexities in maintaining state and sharing information. So with MFEs, it's fine. You can use Redux. If you want to use context, go ahead. Use Mobex for that matter. It doesn't matter. But the problem is you have to pass down state from your shell. Now your shell has some kind of state, not a lot, but like for example, your global feature flags if you have, or your user objects, right? Those things you need to share to your MFEs to say, hey, this user is logged in, or if another user is logged out of it. So those things you have to pass down, but then you have to pass it as a variable because you're not using a state management library on shell per se. and each MFE does not really control it. So when you pass your data from your shell, you need to make sure that if you want to tweak it, then how can you do it? You need to pass a callback to do that, and yeah, a bunch of things, which follows into challenges in auth sharing, which is exactly the same. Authorizing if the user is logged in, log out, how to inform the MFE that, hey, this user logged out from the shell, because the logout feature is not per se on the MFE, right? The MFE doesn't care about if the user is logged in or not. It does care, but it does not control it, is the problem. So that's another issue. Increased testing coverage. So now the problem is that end-to-end tests become difficult because each microfrontend is hosted in its own entity. And now end-to-end test cases, which run from, hey, the user is logging in and then he's interacting with like 5 different modules and logging out. The whole task becomes an issue because you have to go into each microfrontend, you have to take care of what they are trying to do in that microfrontend. Maybe the setup is completely different. Then your test cases need to again tweak to that. So the best way is to have like a very good amount of coverage on each microfrontend, which helps you down the line. Like if that is good, then even if your end-to-end coverage is not possible in completion, you'd still be good. So that's something you need to do. So make sure you allocate time for that. That's one of the basic things. So these were kind of the learnings that we had from our movement. And yeah, now currently there are 8 microfrontends. Each microfrontend now deploys on its own pace. We don't need to wait for anyone. Like I just see 2 years ago the problems that we are in, and now we have completely resolved it. All the issues are only that, hey, plan our sprint, release our product. That's it. We don't care about anything, which is a great help. So yeah, these are kind of the main things. If you want to have a detailed look at, for example, I shared a couple of configs. If you want to have a detailed look, go to my GitHub. It's Pranav Pandey. You can find a small repo there, clone it, fork it, tweak it. You know, for example, if I'm running my localhost on 4000, you can go ahead and run, for example, your builds, right? You can go ahead and run that, whatever changes you want to do, go ahead. I'm on Twitter at PranavPX. I wouldn't suggest you all to give me a follow, but yeah, I post a lot of football content more than tech, so that's there. Yeah, that's about it. Thank you for being a good audience. Thank you for listening.